Thank you, Ismail and team, for having me here. Yeah, 30-second introduction. Sachin, Jade, I am the Chief Product Officer for Cyware. Been with Cyware for 18 months now. Prior to Cyware, ran product and P&L for multiple organizations, Verizon, Deloitte, and so on. And prior to that, for about 10, 11 years, built my own firm, a product firm, that dealt with the early days of EDRs, and what we created this concept called security value at risk, which was what is the value at risk when a whole bunch of security events could happen, so the probability matrix around it. And a lot of traditional AI genetic algorithms and so on. So spent most of my professional career in the security and risk space, so this is very near and dear to me, so I'm glad to be here and talk about it. What I thought I'm going to kind of walk you through the journey, so to speak, is typically how CTI happens from a traditional landscape perspective. So the journey I will take you guys is why does the importance closed loop become really relevant from a CTI operationalization standpoint? A point of view that I wanted to bring about the entire life cycle of any threat event that happens, both from a reactive perspective as well as a proactive standpoint. How do you kind of execute against that particular lifestyle of that threat lifecycle that needs to be operationalized? And for that, what do you need from a platform, solution, offering, processes, and so on? Take a real life example that we did, leveraging our partnerships as well with some of the prominent players out there. I'm going to walk you through that entire flow and how it actually made the entire threat defense much more better, both in terms of that individual enterprise, but also in terms of what we call the collective defense. You will hear that sense of collective defense more and more from me, because I do believe that at some point, the amortization of cost from a threat defense standpoint really becomes much more meaningful when you can share that load with really other people who can do some things for you as well. So the power of community, the power of network. And then I'll end it up with some of the takeaways, and time permitting, absolutely questions as well. So let's dive into the details. I love this because as defense individuals that we are in our enterprises, we kind of forget this sometimes. We typically, we are playing by our rules, we're playing by legal frameworks, etc., the governance, the regulations, the compliance. Threat actors do not have to play by the rules. They'll leverage any attack that is possible, coerce, your colleagues, unfortunately, or some other individuals from the outside world to take advantage and exploit some of the capabilities around there. Both old new techniques, a lot of times when, defense as a CTI, as an SOC, we tend to move away from what has been to what is going on right now or maybe in the future. So emerging technologies, emerging threat areas, emerging techniques, etc. But then we kind of lose track of some of the old ones. And then lo and behold, at some point, the older technique is brought in again in collaboration with the new ones. And so then your TTPs kind of go for a toss. How do you start leveraging that human and non-human component that they do? And then, of course, with the emergence of AI, you have so many new things that are coming up. There was a very interesting article that came maybe about 1 or 2 days ago with respect to how generative AI can now be used significantly in attacking password components with significantly rich and real-looking phishing techniques behind the scenes as well. Out of all of them, the last one is my key, which is they will collude when they need. And so they will share information with others appropriately so that threat actor A can benefit in one way, threat actor B can benefit in another way, and they will keep colluding in one way, shape, or form. Why don't we do that properly in our landscape sometimes? We cannot just leave it by ourselves. And so what we did was we conducted a survey in RSA last year. And as you can see, overwhelming majority, everybody wants to have that sharing capability because everybody understands that's extremely critical. But just about a little bit more than half is yeah, we can't do it because it's very complex. So what are the challenges in that CTI space that typically happens and because of which it becomes extremely complicated from a TCO and an operations standpoint? You've got a whole bunch of different sources coming in like any other. You've got data overload, and then you've got the threat visibility that starts to become more blurry as opposed to more focused. So the relevancy factor starts to degrade. And you will hear that notion as well, because you will see me emphasize on relevancy, relevancy, relevancy. If it is not relevant to you, it needs to be taken a notch down, so to speak, right? So how do you find that relevancy? And in that threat visibility, blurriness, if you will, a lot of that emphasis goes around the IOCs, the traditional IOCs, which is absolutely a must. But it has to get evolved also in terms of that behavior, because what we saw, they don't play by the rules, which means they'll keep changing certain things in terms of like what IOCs they want to use, what IP domains they might want to use, how DDoS ones they want to do, etc. But the behavior technique is something that they still kind of gravitate towards. So how do we figure out that attack flow chain? It's very complex sometimes to set it up. So you need a platform. In addition to that, you need data input feeds from a whole bunch of different things. Then you need some kind of an orchestration capability so that you can integrate with your internal systems, your external systems, etc. And so, unfortunately, an outcome of that becomes that point number 4, which is a lot of that manual process starts to kick in because it is so cumbersome at times to set it up. And so that entire swivel chair becomes. And so these are all the challenges that we have, I think, seen in everybody in their own enterprises as well. And so when I take that next lens of this, which is if I wanted to make this into a little bit more efficient, what's stopping it? That data overload. We get so much data. Now, which data feed is important? How do I figure out the ROI of that data? So that becomes extremely critical from a data overload standpoint, which is relevancy, relevancy, relevancy. And the last, that alignment to that CART framework, was at an event, last month actually, and the teacher there uses this completeness, accuracy, relevancy, timeliness, etc. Right, and so we spoke about this significant, multiple times, and kind of came to consensus that relevancy is that significantly overwhelming majority as opposed to the others, because if it's not relevant to you, take it down a notch. Manual workflow, well, as we just discussed, so many things, both in terms of checking the efficacy of that intel. When the intel comes in, because CTI is often perceived as research, which is, okay, you will have to do a whole bunch of analysis by yourself, maybe a few individuals, and sometimes that do more with less. Focus cannot be accomplished appropriately with an enterprise. And so you have to then take corners, and then that manual check on the efficacy of that intel starts to degrade significantly. That signal to noise ratio really degrades very quickly. And then the handoff to SOX because of that, that sharing that is needed. So you do part of that sharing, but because it's not automated, because it's not efficient, because the correlation around what should be shared, at what point do you want to share, etc., is not built in an automated fashion, it literally degrades again. And then the feedback, and this is where the closed loop system becomes extremely important, and I'll go into it in the next few slides. The static and in a context lacking information. Detections and the detection engineering sometimes are based on that static information that may come, and because the adversaries are not, and because they change, and the behavior techniques have to be leveraged appropriately. And so that detection engineering has to take not only the IOCs into the equation, but the entire IOB framework as well, so that you start to understand that what is the behavior, what is the technique, what is the probability of the next TTP or the next technique that is going to be leveraged. And so for that, proactively, what is the detection logic that I need to send to my SIEM or some other place as well? So that entire context has to be built appropriately. And so what that also means is the actions, which usually will work on stale data, now has to change. So let's look at, if I wanted to now bring in that whole concept of closed loop in operationalization, why does it become important, right? Typical procedure, what happens is, you've got the collection and curation of data. You're getting it from your feeds, from your ISACs, from your ISAOs, internal telemetry, etc. So this cycle, kind of starts to kick in. Then you get the enrichment of that data that you want from some other source. You want to figure out what are the other related objects, especially if you're working on an SDO, SRO kind of a concept. What are the other threat actors that might be leveraging this IP as well? If this is getting used, is it in some sort of a command control system? Is it something else? How do I get a little bit more data around the domains? Are these domains that are unhealthy, etc. Right? So you start enriching it a little bit. Then in one way, shape, or form, you start to translate it into the detection logic, saying, yeah, great, you know what, now I know what to do, what do I look for from a detection standpoint. These are these IPs, these are these domains, these are these CVEs that I need to be worrying about, etc. Right? That's the latest one that came through. And then I give it to some sort of a SOAR mechanism at one point and say, great, you know what, I've given it, you can now start taking action against one way, shape, or form based on the detection logic and detection, something that was detected. If that feedback loop is not there that you see in the middle, everything that you have put in here, the decay factor of the efficiency of this process, the half-life period is so small that you start to degrade the entire process very quickly. Because the efficacy of that very first step, which is this intel that I need to now take forward to enrich, to do the detection engineering around it, to change some of the Yara rules, etc., to figure out where I do need to take action against. If that signal of that intent of that intel is not provided by that feedback saying, hey, I actually took an action based on the intel that you provided, every other step you are putting in so much effort, but the ROI goes on a negative lens. So that entire concept of getting the information saying, great, I got the intel, but actually did something with it, either in the positive say or the negative, which is this was meaningful to me or it was not meaningful to me, I adjust the score. The entire scoring of this has to be in a very dynamic fashion, which means once the next time this intel comes in, you absolutely now know it's relevant, this has happened before, etc. Now, if that has happened before, this also means that you may have set it up properly to take action against it. So very quickly in an automated fashion, for instead of going through the entire enrichment detection logic, and you now kind of go to the fourth step directly, which is, hey, I know the response that I need to take. My agent, my component, etc., can now take that action if it hasn't been, for example, patched and so on, right? So it really makes the process much more efficient. So the operationalization of CTI itself is pretty hard because you need to have a lot of different things, but you can take it up a notch in terms of the efficiency, and your executives will really like it because now they're getting the high ROI by leveraging feedback loop in the mix. And from our point of view, this needs to be fully automated because anytime you introduce a manual component within the mix, the efficacy of this process starts to degrade again, and CTI then just becomes its own bubble, unfortunately, without giving the right information to the left, from the left hand to the right hand, so to speak. And so, this is our methodology, our framework. It's built into our product as well. And so, as you see, you can get that intel incoming data across all of different IOCs, indicators, STOs, SROs, TTPs, etc., from lots of different places. And it's already baked in. And so this is why it makes that complexity of setting something up really go down. Your time to value is enriched here already. You get the data. Once you get the data, you're deduplicating it, you're cleaning it up, you're making sure that it is getting the right information that is relevant to you. Now that's that first relevancy score that you got. Now you're now starting to correlate and normalize. This is correlation against not only the different multiple signals that you might be getting from other feeds, etc., because that now also allows you to find out what the ROI of a particular feed system could be. It could be from an internal system. Is it really adding value, etc., or not? Then comes the threat enrichment that we spoke about, which is, this is relevant to me. This is actually more relevant based on the second criteria about correlating it with my internal telemetry, my internal assets, and so on. So now let me start enriching it more and more from different areas. Once I start to get that enriched data, now let me start to figure out the risk scoring as well. Now, the beauty of this risk scoring is you can now make that risk scoring go any which way in that entire process. We put it in this area because you've kind of taken that first step of like, this intel is relevant. So now let me figure out what the risk of this intel is from a scoring standpoint. And in this scoring model, it's extremely important on how you actually create the models. Going back to that threat attack, the threat actors don't play by rules, bringing in old techniques, new techniques, etc. So the risk model that we've kind of built, the scoring model that we've built, kind of starts to take into effect the time decay factor as well. So it gives a lot of flexibility in terms of weightage for which kind of input it's coming from, what kind of actions you can take from it, what are the relevancy with respect to the internal asset and the internal telemetry and so on. But in addition to that, the time. because the time also gives you an idea of like, is this now more relevant because it just happened, or is it less relevant because it happened sometime back, or law of averages, is it going to come back up again? And it has a default model. You can tweak it. You can start building scenarios around it, and you can actually run the scenarios to figure out what that risk scoring should be. Last but not the least, now it comes to like, okay, now I need to share. And again, no manual intervention. Let's start automated from a sharing standpoint, both in a tactical capacity as well as a human strategic, advisory or an alert as well. Going to different areas, both your EDRs of the world, the action SOAR responses systems, including our own, and then you also have it sent to other counterparts that you might want to send it to who can actually leverage it. And we'll actually walk through this scenario in a real life use case that we used. So this brings that life cycle of the entire threat intel from an operationalization standpoint. And that last part of the sharing and publishing that brings back that feedback loop, which is, hey, you know what, it actually went in. The next input that comes in comes from the systems that actually took some action against it as well, which means that input now was also sent to the risk scoring. So your risk scoring changed appropriately from a prioritization standpoint. So that's that whole entire closed loop mechanism that is extremely important. What I wanted to bring to bear is, given the landscape of enterprises, you have Fortune 100s, the mid-markets, et cetera, right? And so which means you've got a maturity scale that you need to build certain things around. And so anybody who has used the CMM from a CTI standpoint kind of is aware of this. In all of this area, the statistical distribution, if you see from where most enterprises lie, is somewhere in the 1 to 2 range, which is like, I've got the basic integration done. I have some of the IOCs go in, and I have an idea of like what the contextual information is, especially with respect to my CMDB, my internal assets, and so on. But after that, all of the things are sort of kind of fragmented in a way. And so we want to bring that journey for customers and practitioners to say, if you start building capability around any which way, that central concept of that contextual intelligence and that automated correlation, do not let go of that, because anything that you bring in addition to that only makes the entire problem statement more challenging. You get the basic integration, a lot of people do. The contextual intelligence needs to be really strong, so that you actually now start to figure out whether it's the risk scoring around it, what is it relevant to me when the actual internal asset and internal telemetry has changed, and so on. And then the behavior, that automated correlation around the behavior. This needs to run a whole bunch of different scenarios. Think of it almost like the Google search model that was there back in the days. It would crawl and start figuring out the page ranking and figuring out the scenarios around it. What it is very similar to that. You need to run a few different scenarios. This is the technique that threat actors are using from an adversarial standpoint, seeing different scenarios around the password hack that I was talking about from a genetic algorithm standpoint, or somewhere else as well. And so for defense, we need to be running different scenarios. But to run those different scenarios, you need that intelligence that has to be brought in. But in addition to that, you need the data to be also shared from other individuals in your neighborhood, be it your supply chain, be it your third-party vendors that you're working with, be your other counterparts. You're in the healthcare space, another medical device company that you work with, you're in financial services space, another hedge fund, another banking institutions, etc. Right? So that sharing is needed, because then you start to build those scenarios based on other data as well, without having to take on all the costs around it. Last but not the least, after once you get the automated response, is that closed loop intelligence. Because that closed loop intelligence, again, is not only for your own enterprise, but then start to share it with the counterparts around it. Because what that allows, again, is, let's say, and we'll walk through that use case, once I have taken a decision around a EDR, around blocking a firewall, around patching certain things, etc., when I send this data, traditionally it's always been, hey, there's an advisory, let me share the advisory. But when I share the advisory or the intel around it, I share the recommended action that you should be taking, as well as what decisions I have done to actually block this threat, so to speak. That is such a powerful mechanism for the counterparty or the audience on the other side to start taking it and be ahead of the game already. That is proactiveness. So that becomes extremely important from a closed loop standpoint. In addition to that, the reason there's one area of this false positive that I wanted to bring in a number of iterations that we did within our model as well, we started realizing that you have to have that capability around your model to start reducing those false positives very quickly. A lot of the times you do have that, you do go through your processes, etc., and then at that point you start reducing those false positives and so on. But you need to bring it up very quickly so that the signal to noise ratio goes up significantly, because threat attackers do it in milliseconds in terms of like what they want to do. Once they have penetrated, the lateral movement, etc., starts becoming pretty critical, interesting, and so on. And so from how to do all of those areas from false positive standpoint becomes extremely critical. So the way we've done it is we started off with the reliability scoping model, which is we actually bring in a whole lot of data, including what it means in terms of the context. And so by definition, we create a threshold of that false positive rate already around what it is we have seen before. Then we bring in the multi-signal correlation, internal, external, internal telemetry, etc., all of those things to start figuring out, okay, what is this really relevant? Going back to a CART framework, is this relevant? Is this relevant? Is this relevant? The difference is we bring in the behavior and the analytics as well. So not just the traditional tactical IOCs, but the behavioral analytics saying, okay, if I know that this is the threat attack, that was typical flow chain of the 6 or 7 different ways that they do, then can I start to figure out what the behavior looks like if this is important to me? The aging policy. This in conjunction with the behavior starts to give me an identification saying, you know what, this is probably not needed right now because this individual typically does not go to the same thing after three attempts or 3 tries or 3 months, etc. So that kind of behavior pattern that we can identify allows you to start figuring out that simulation that you need and take down the notch from an aging standpoint. The confidence and thresholds, and these are dynamic in nature, right? Typically, the CTI analyst, SOC analyst will create one to start off with, and then you start changing that appropriately. This changing, especially from a kill chain mapping standpoint, becomes extremely important when you're in dynamic nature. So that false positive again. And then last but not the least, the human validation for automation. Everybody is doing some form of AI, agentic, etc. Sure, we've got ours as well. What I truly believe is, given that they are also functionally doing something similar to another human analyst or a SOC analyst or a CTI analyst, etc., team member is doing, so to speak, very similar to how in the human world, when you have to start trusting certain team members, etc., it takes a little bit of time. Similarly, to start trusting what that agent is doing, what that AI is doing, how is the chain of reasoning thought model is working behind the scenes, or if it is a combination of a RAG and a vector, etc., how is that working, and so on. The decision factors that this quote unquote interpretation of the telemetry, is it the right interpretation? Is it a lateral movement that's going to happen? Is it not? And so on. If there's an automated decision that is being taken, it needs to be validated. And at some point, you start to gain that trust, enough trust so that they can now start to do certain things by themselves. So this is how the false positive starts to become extremely important. Another tool in your belt to say, you know what, the operationalization of CTI becomes much more efficient. Now, kind of switching gears, we saw the point of view, the hypothesis, how we actually built a whole bunch of things, real life use case, where the rubber meets the road. So, a few of the customers as well. We worked with Microsoft on, with their Sentinel and Defender on the EDR side. And we started looking at how that entire bidirectionality needs to happen, both in terms of getting the data from our platform, so to speak, from an external threat vectors that we see, what is the attack surface, what are the IOCs, what are the LBs, etc., sending it to, let's say, for example, a SIEM system. But then in addition to that, the reverse that's coming from them and going into the EDR space, that to actually do the final response as well, whether it's blocking, patching, etc., for SIEM to have the detection of like, hey, you know what, I saw this alert, I saw this IOC, I saw the component around it, and so on. So the 4 core blocks around it that we have, which was that automatic ingestion, which was again automation, so that you're already at that maturity curve in that CTI CMM level. Then you've got the bidirectionality, which means now you've brought in the closed loop component around it. the enrichment, which is needed for your risk scoring, which means your relevancy factor. And last but not the least is that proactive hunting, which is that, okay, I got everything. Can I do something more with it now because I can share with somebody else, or I can take certain proactive defense measure around it. So the customer healthcare space, the way it kind of, the architecture, so to speak, the way it runs around is a whole significant number as any other platform from data standpoint. Everything that I said with respect to that lifecycle event comes into our Intel Exchange platform, which is our unified threat intel management solution. Along with that, the data that's coming from the internal source as well, coming from Sentinel and any other systems that they may have and so on, right? So that's coming in. We've got what we call our other product, which is tightly integrated with Intel Exchange. That's our Orchestrate platform. And the Orchestrate platform is, by very nature, does integrations with about 400 integration components behind the scenes, and also has the capability to invoke any AI as needed. And this is where it's very tactical and very deliberate in terms of when you leverage AI and when you don't. And so, for example, the agentic nodes that are present, they will take the actions when it is semi-deterministic about what needs to do as the next step, so to speak. And so it comes into Intel Exchange. Intel Exchange is working on all of the data appropriately. The detection logic, it figures out what the detection logic could be around based on all the parameters, the risk scoring, the IOBs, the attack chain, what the TTBs could be, etc. So what should we be looking for in multiple different ways, sending it to my Sentinel. In addition to that, because of Orchestrate that has already integrated with Defender, sends it to certain Defender components as well so that it can actually take the response appropriately. In addition to that, now when this healthcare enterprise found this in certain cases, when they took the actual decision around it, that would come in to Intel Exchange and it will change the scoring, the relevancy, the component around it, everything in an automated way. And to make it even more powerful now, not only did that particular healthcare enterprise was able to take care of it, but because they're working with your supply chain, third-party vendors, all of those things as well, you can now send it to all the members that are part of your group, so to speak, or you have counterparties who are using their firewalls and SIEMs and so on. And this has now created that collective defense. So now, not only did I create a defense from a closed loop standpoint just for my own enterprise, but I shared it and what we call the automated collective defense. We created that kind of a layer for all our supply chain, third-party vendors, and so on. So that's what makes it extremely powerful, not only based on certain decisions that were taken, but the relevancy of that, etc. Right? So that entire thing has been sent across, and our members can take the decisions that are relevant to them. Again, that relevancy factor. It's very much the analogy is very much to Team of Teams. If folks have read that book, which is you send the data that is relevant appropriately that we believe, and then the corresponding party on the other side takes the action that is most appropriate, from their standpoint. And so you've got a completely closed loop incident intelligence layer inside the security stack, completely automated. So this is that CMM level 5, so to speak, which is like you got the data in an automated fashion. And because Intel Exchange already comes up with what we call the intelligence suite, you have the platform, you've got the feeds, you've got the scoring mechanism, you've got the rules, you've got the integration, etc. So day zero, you're operational, and as well as that automation that starts to kick in as you bring on the other components within the internal ecosystem as well. So that's what we did. So you saw the journey, how CTI has to evolve from that static research mindset to more of that, more full flow. And so that SOC teams, CTI teams start to work with each other and so on. We looked at, how do you kind of evolve, so to speak, with the closed loop becoming a centerpiece and not to leave that for an afterthought, so to speak. Bringing it in real, how we did it here appropriately, so that it gives you a flavor of how to do it and what are the key components that to be focusing on. So having said that, kind of the closing summary, I kind of alluded to that. You've got the automated workflows in one way, shape, or form. Behavioral intelligence, I do stress on it quite a bit because it is that next layer of understanding what the IOB start to look like and what is this threat actor trying to do certain things with it from a next step perspective. that correlation to make it relevant, and then take the action against the automated response from a detection logic and also the actual actioning itself. And then do not forget the continuous feedback loop, both for yourself, the enterprises, and try to share it with others who can actually then take advantage of that and so on. With that, I believe, thank you. Thank you so much, Ismail and team, for having me here. And hopefully this was helpful to the team as well.